Okay, so today we're going to be doing another Thevenin equivalent circuit. As you can see, the load is in the middle of the circuit. What do we do the first thing with a Thevenin equivalent circuit is we remove the load. So we're going to remove that load and put it in our Thevenin equivalent circuit over here. So we have 4.75K ohms. That's our load resistor in our Thevenin equivalent circuit. So now we can remove the load. Bam. So what we need to do is get voltage A to B or A to B, whichever way doesn't matter. What type of circuit do we have right now? That's right, you have a series circuit. So how do we get E total in a series circuit? We always start here, we go around the circuit, only looking at the battery. So we have a -5 minus 10, so we have E total of 15 volts, and the polarity is going clockwise here. So it's plus to minus, plus to minus. So the voltage drops on the 1K and the 2.2K have to equal what? 15 volts. So we have 4.69 volts here. Okay. And then we have 10.31 volts here. So now we can do voltage A to B. If we start at A and go up to the right, it's plus 10.31 volts minus 5 volts is going to give you 5.31 volts. That's going this way. Plus 10.31 minus 5, back to B, is 5.31 volts. If we go the opposite way, we'll be negative 4.69 volts plus 10 volts. You should get the same thing, 5.31 volts. So your VTH we can now place on the Thevenin equivalent circuit of 5.31 volts. And now we know the direction is going to go this way, A to B. So far we have VTH for the Thevenin equivalent circuit, and we have the load resistor here. The last thing we need to get is RTH. So we use the look-back method. What we do is we put a pretend battery where we took out the load, so that would be here, and then we short batteries and open currents, but in this case we only have batteries. So if you look at this, if there was a battery here, what's the relationship between the 1K and the 2.2K ohm resistor? That's right, they're in parallel. When you get the parallel combination, you should get 687.5 ohms. So 687.50 ohms when you put 1K in parallel with 2.2K. So now we bring that back to our Thevenin equivalent circuit, and that is our RTH of 687.50 ohms. Last but not least, and what we're trying to do with Thevenin equivalents is get the voltage across the load within the Thevenin equivalent circuit. You will always see a Thevenin equivalent circuit with a battery, which is VTH, with another resistor, RTH, and then the load. So we're going to use the voltage divider rule. So to get VRL, which is the load, it's E total, which is 5.31 volts, times the resistor one we want to get the voltage across, 4.75 volts, divided by the total, 687.50 ohms plus 4.75 volts. I'll give you a second and see if you can get that voltage drop.
Should be 4.75 K ohms, not volts. No, volts up there, or K ohms there too. You're putting volts in everything.
So I I know that you probably thought I put volts there, but I was just testing you guys. So you should get 4.64 volts, 4.64 volts for the voltage across the load within the Thevenin equivalent circuit. Have fun!